Okay, let's dive into this explainer and tackle what is honestly a growing headache for all of us. Building AI agents with scattered, high-maintenance, custom API integrations. If you've been working in the AI engineering space recently, well, you know exactly what I'm talking about. We are constantly trying to connect our large language models to this massive myriad of external databases, files, and web services. And sure, it's powerful, but structurally, it's becoming a total nightmare to maintain. So today, we're going to look at a real game changer for this problem, the Model Context Protocol, or MCP for short.
To help you master this, especially the basic steps of implementation, we are going to trace exactly how a query travels through the system. We'll hit the integration challenge, introduce the MCP standard itself, walk step by step through the implementation flow, break down the core components, and finally wrap up with the overarching advantages. Section 1, the integration challenge, dealing with scattered APIs. Let's think about the traditional method for a second. It's essentially a web of custom API integrations. Every single time you want your AI to talk to a new tool, it requires manual setup and documentation for every single endpoint. It is incredibly hard to scale. But the MCP approach? It replaces all that custom chaos with a standardized plug-and-play protocol. It scales easily as you add more tools because, well, they all speak the exact same language now. It even features a built-in discovery mechanism. So instead of constantly reworking traditional integrations, you get a centralized, highly scalable standard. Section 2, introducing MCP, the open standard. So what actually is this protocol? The crucial thing to know is that MCP is an open standard introduced by Anthropic. You can think of it like a universal translator. It connects large language models with external tools, APIs, databases, and files using just one standard communication protocol. It literally eliminates the need for all those custom integrations we were just complaining about. It gives you a single, reusable architecture to securely connect your AI assistant to virtually any external application or file system you can imagine. If we visualize the high-level architecture, there's this beautiful, clean, linear flow. At the very top, you have the user interacting with the AI assistant. But right below that is where the real magic happens. The AI connects to an MCP client, which bridges over to an MCP server, and then that server branches out into your tools, APIs, databases, whatever you need. Once the data is grabbed, the response flows right back up that exact same chain to the user. It is highly structured, secure, and totally modular. Section 3, the implementation flow, a step-by-step journey. This is where we really want to focus today, mastering the basic steps of implementation by following a single user request in real time. Step 1 begins simply enough. The user sends a query. From there, in Step 2, the LLM processes that input and figures out the underlying intent. Basically, it realizes, hey, I need outside information to answer this. Step 3 is the handoff. The MCP client takes that intent and securely fires a request over to the MCP server. In Step 4, the server gets the request and intelligently picks the right tool from its arsenal. And finally, Step 5, the tool executes its function. That could be running a database query, executing a Python script, you name it. It is incredibly clean. Okay, so the tool has executed, which brings us to the critical return loop. In Step 6, the response from the tool is safely returned back through the server and client to the AI assistant. And then, in Step 7, the LLM takes that newly acquired external data and generates a highly informed, perfectly accurate final answer for the user. It's this elegant 7-step communication flow that literally happens behind the scenes in milliseconds. Section 4, core components. Let's rapidly break down the tech stack that makes those steps possible. First up is the MCP host. This is simply the overarching application or environment where your AI actually lives. It's the primary interface utilizing the protocol. Next is the MCP client. Think of the client as the messenger. It sits right within or alongside the host, and it handles the critical job of outward communication. It formats the LLM's intent into the standardized protocol and securely sends it across the gap to the server. And on the receiving end, we have the MCP server. This component catches those requests from the client. Its whole job is to expose the specific functions, tools, and resources your AI needs. It's basically the gatekeeper to the outside world. What's absolutely fascinating here is the sheer variety of what that server can expose. We're talking basic resources like local files, PDFs, and images, but it scales all the way up to complex executable tools. Your AI can tap into cloud storage, parse GitHub repos, use calculators, trigger web browsers, run heavy database queries, and even execute Python code live. And because they all connect through the exact same standard, adding any of these to your AI agent requires zero custom integration rework. Zero.
Section 5, the MCP advantage. Why should you actually standardize?
Let's connect all this back to your daily workflow. When you stack these approaches up against each other, the takeaways are pretty stark. With standardization, MCP gives you one protocol for everything. Traditional methods, they leave you juggling a dozen different APIs and formats. On security, MCP has built-in practices, while traditional methods require you to reinvent the wheel every time. Reusability is extremely high with MCP. Your tools and prompts are fully reusable across environments. Ultimately, you're trading scattered high-maintenance code for a centralized system that is just so much easier to maintain. Looking at the overarching ecosystem benefits, you get a system that is inherently secure, extensible, and modular. You can literally swap tools in and out without breaking the whole shebang. It's cross-platform, which means seamless interoperability. And the result? Significantly faster development times and vastly better tool integration. You are laying the ultimate, scalable foundation for building modern autonomous AI agents. So, I'll leave you with this final thought. Considering the massive overhead of maintaining custom endpoints and the totally elegant 7-step communication flow we just explored, isn't it time to standardize your AI ecosystem? The future of scalable AI agents clearly relies on open standards, and MCP is giving us the exact blueprint to get there. Thanks for joining me on this explainer, and happy building!